So let's say we want to look at mixture problems here. This will be a short discussion on how you can lay out and do this particular class of problems. So let's start out with, say, a bag of balls. So let's say in this bag of balls you have several blue ones and several red ones. And what you want to do is add those to another bag that has another mixture of red and blue balls. So what you get then, combining the two, of course, all the blue balls and all the red balls will just add up to whatever their numbers are. So let's say in this illustration we have 12 balls in the first bag, 8 balls in the second bag, and so when we combine them, we're going to get 20 balls. Now, if we just look at the red balls, in the first bag it looks like we have 3 red balls, and in the second bag we have 5 red balls. So we add those two together, and what do you get? You get, of course, 8 balls. So these mixture problems really are nothing more than just doing a version of this problem where you're using solutions or percentages of one component in another. So let's look at the percentages of red balls in these bags. So the first one, since we have 3 out of 12 balls are in the first one, that would mean 25% of the balls are red. In the second bag we have 5 out of 8, which is 62.5%, which is 5 divided by 8. And then in the last bag, where both of them are mixed, we have a total of 40% of the balls are red. Now, if you notice between the numbers, there doesn't seem to be any particular relationship between the percentages. You know, they certainly don't add up, or they don't average to 40%. But when you do the count of them, of course, the count is exact. 12 plus 8 equals 20, and 3 plus 5 equals 8. So in order to do these kinds of problems with percentages, what we want to do is we want to take a look at the percentage that you have in the bag of red balls times the number of balls total, and you get the number of red balls. So with this equation here, we can translate the amount of the percentage of red balls into a number of red balls. And so if we do this for all 3 bags, we'll see we can take 25% of 12, which means there's 3 balls in the first bag, 62.5% of 8 balls, which works out to 5, and then 40% of 20 balls is 8, right? 0.4 times 20 is 8. So when we do mixture problems, we're going to make use of that second equation. And so let's look at kind of a general model for the mixtures. First, we have the overall amounts, and so the total volume of the first quantity plus the total volume of the second quantity will equal the total volume of both quantities combined. Now, if we look at the concentrations, we'll see, if we're looking at a particular ingredient, the amount of that ingredient in volume A is going to be whatever the concentration is in A, and multiply it by the total volume, and you get the amount of that particular ingredient in A. Do the same thing with B, where we'll take its concentration in B and multiply it to the total volume in B, and that's the amount of that ingredient in solution B. And when you mix them together, then you get a concentration of the mix times the total volume will be the total amount of that particular ingredient that you're looking at. So the key to these things now, when you're using these this model, is that we want to define our variables carefully, and we're going to make an equation with one variable, and I'll show you how to do that. So let's say we have an example here. We have a 2-pound bag of mixed nuts, and it contains 20% cashews. And let's say we have another bag that's 3 pounds of a nut mixture, and it contains 10% cashews. When we mix these, what percent of the mix is cashews? Okay, so if we go back to our model, we say, okay, the total weight is going to be bag A plus bag B is the total mix, and for cashews, it's the percent of cashews in A times the volume of bag A, the percentage of cashews in bag B times bag B, and that'll be the total amount of cashews we have in the mix. So if I make a formula here, I have 2 pounds plus 3 pounds, I'm going to have a total of 5 pounds. And then here, this is the more subtle part, I'm going to take my 20% of 2 pounds of cashews. That means I'm going to have 0.4 pounds of cashews from the first bag. And then I'm going to take 10% of 3 pounds, and so I'll have 0.3 pounds of cashews. And so my total is going to be, when I add those two together, I get 7/10 of a pound of cashews. So what this means then is if I take the 0.7 pounds of cashews divided by 5 pounds, which is the total volume that I have, including all the nuts, what I get is essentially 14 over 100, or 14% of my bag is going to be cashews. So let's look at another example. This one will be perhaps a little bit more complicated. So let's say you have a 10% solution and a 60% solution of antifreeze. So you have two different values. How much of each should you mix together to get 10 gallons of a 50% solution? So now you really don't know how much of each you're going to mix, but when you mix them together you'll get 10 pounds, and it's going to be half antifreeze. So in other words, you're going to be taking this more concentrated solution here, 60%, you're going to add a little bit more of this, we're going to add some of this dilute solution, and so that'll average down the total concentration of the antifreeze in water. So let's set this up with our equations using our model. Okay, so let's say X is the amount of gallons of 10% solution that we're going to use. Now we could make another variable that says, oh, well, let's use Y as the gallons of 60% solution. But we already know that X plus Y equals 10, so why don't we just use X as our 10% solution, and then 10 minus X is the amount of the 60% solution, right? So if it takes 1 gallon of the 10% solution, it'll take 10 minus 1, or 9 gallons of the 60% solution to make 10 gallons. Okay, so when we have the 10% solution and the 60% solution together, they're going to make 10 gallons. Okay, so let's look at our concentrations now. If you look at, you have 10% of the amount of the solution you have in this in X is 10% of X is going to be the antifreeze, and then we take the amount that we have in the 60% solution, so this is the total volume, times 60% will be the amount of antifreeze in there, and this is what we're going to want. We're going to want 50% of 10 gallons will be the antifreeze. Okay, so if we then expand this out, we'll distribute the 0.6 over the 10 minus X, and we get 6 right here. So we get 6 minus 0.6X, and so when we take the 0.1X minus the 0.6X, that's going to simplify to minus 0.5X, and then we'll subtract 6 from both sides, and so we have 5 minus 6, and so ultimately we know that X equals negative 1 over negative 0.5. If I simplify that, I get 2. Okay, so then we know that we need 2 gallons of the 10% solution, and we need 8 gallons then of the 60% solution, because we know that the 60% solution is going to be 10 minus X, so 10 minus 2 is 8. So I answer my question with a full sentence. You need 2 gallons of the 10% plus 8 gallons of a 60% solution to make 10 gallons of a 50% solution. So we can check this, and if we put it in our original model with all the known numbers, 10% of 2 gallons plus 60% of 8 gallons is 50% of 10 gallons, and indeed 0.2 plus 4.8 equals 5, and so certainly 5 equals 5.